Hi, welcome to SN and in today's video I'll try to explain you what is transfer learning and why do we need transfer learning and how to transfer learning works. I'll show you with an example in Colab. Okay. So first what is transfer learning? So as per the wording you'd understand it simply means you have to transfer the knowledge base from one model to another model. And what is this knowledge base mean in this case? It simply means the biases and the weights your one deep learning model have been trained with. Okay, you simply have to transfer that weights and bias to another model where you have to just change the output layer so that it can predict a new data. That's it. Now I'll show you all this through some diagram and through codes. Now the second question is, why do you need transfer learning? Number one, we mainly need transfer learning in deep learning domain, not in machine learning, right? And why that? Because in machine learning now you can, like, let's say you have 10 requirements that you need to solve using a machine learning models. You can create 10 machine learning models because machine learning model doesn't require lakhs of data to be given proper accuracy of model, right? Like you can train a 90 to 95% of machine learning model using 10 to 20,000 of data, but that is not the case of deep learning. In deep learning, if you are using 10,000 to 20,000 data, it for sure gonna give you some overfitted result, right? So that's why to build a good efficient deep learning model with like of course with neural network, it requires millions of data with millions of parameters, and that is not easy to train with. That is computationally heavily expensive. You need high level of GPUs, high level of setup for that, right? So that's the first problem. And second problem is deep learning is designed to work in isolation task. Like you can, like if you create a deep learning model for a particular task, that will be only tackle one single task, that cannot tackle a different domain of task, right? But as you know, neural network, that whole concept comes from a human brain, and we have tends to use one knowledge base to tackle another question. Like if I give you some easy example, let's say for our JEE mains preparation, if we, like, whatever practices we do in our coaching, that's not the question we're gonna come in our mains exam, right? But it's all about the knowledge. If we got the proper knowledge in our practice, we can easily use that knowledge to tackle our question that we'll be getting in our mains exam. It's that simple. It's all about the to to get the proper knowledge so that you can tackle multiple questions through that. It's that simple. Now there are multiple use cases of it. Like you know that there are Hugging Face transformers that give you some pre-trained model that you can fine tune as per your requirement. Like we have bot, we have GPT. Now in recent time we have, like, we have DeepSeek. So we'll be doing lots of projects on those transformers, but in this video I'll just try to show you some basic example how transformer works. So that's it. And now let's see some diagram, because it's always easy to understand the whole transfer learning concept through some diagram. Okay, this section you'd see that it says traditional machine learning or deep learning model, and what it does, it has a set of data set, and it goes to the learning system. And what is the learning system contains? It contains all those machine learning model, or all those deep learning models. Okay, and so this is the first model and this is the second model. But for the second model, it's same technique. You have to use lots of data and you train the model to get a proper result. But for transfer learning, what it works, in the first model you put, let's say you give millions of data to train the first model. Now at the time of training, you have got the final weight and biases. Now you simply transfer that weight and bias to a new model. Okay, but then also you put some small amount of data. Let's say for the first case you are given a million. For this case you were giving, let's say, 1 lakh of data to train. But the thing is, it will train faster, and in some case it might work better than the previous model, right? So that's a simple diagram of it. And if you see the workflow, you'd see that you just simply need to load weights of a pre-trained deep learning model. From there you need to remove the last output layer, because in the second model you would be given a different type of data set, right? So your output will be different. Then you need to attach a new layers of suitable for work as per your requirement. Then you need to hold the weights of pre-trained model. Then from there you need to train the new data set. Then you will see that the transfer learning of an optimized model key, most of the time your second model will work better than your previous model. Okay, so these are the some theory and some concept about transfer learning. Now let's get to the code and let's see how transfer learning works. Okay, so first we need to import our libraries and function, right? So for that we'll be importing our print function from future, and we'll be importing time from time. We'll be importing keras. We'll be importing mnish dataset with CIFAR-10 with from keras dataset. Be importing sequential and dense dropout activation and flatten functions. We'll be importing convolution 2D or max pooling, Adam optimizer, and backend SK. Then to show our accuracy, we need to plot the graph. So for that we'll be needing matplotlib.pyplot and some random functions. Okay, let me connect my GPU. It's already connect, so wait a minute, it's connecting, right? So just wait a couple of minutes, a couple of seconds, yeah. And okay, so our next step would be to set our filter size, our pool size, and our kernel size. Okay, and we'll be needing filters in our convolution pool size to pulling the main pixels from our images, and also we need to set our kernel size to set our neural network. So let's run this cell. Okay, now our next step would be to load and split the data between train and test sets. So we are downloading our CIFAR10.load data. We are downloading the data set in here, and we need to break that into train and testing set, right? Like some basic process, some basic process of deep learning. It's downloading the whole data. So yeah, now we need to figure out, and now we need to reshape our train and testing dataset. So 50,000 for training and 10,000 for testing, right? Now here is the thing, we need to create two dataset, one with level class 5 like below 5 and one with above 5. And why is that? Because for this level of below 5 we'll be using that to train our first model. From there we'll be taking our knowledge base and we'll be using that for our second model that will be trained with above 5 levels. Okay, so let's run this. Okay, now let's show you what are the data set we have and what are the types of images we have, right? So here we go, we have this 10 categories of data set. We have airplane, automobile, bird, cat, deer, dog, frog, horses, sheep, and truck. Now we'll be using these fast categories like airplane, automobile, bird, cat, deer, and yeah, deer. This 5 to 10 our first model. We'll learn our knowledge base from here. We'll use that to train our next 5 categories of dataset. Okay, so let's see what are the dataset we have. So this particular cell is to give us the images for the first 5 categories, right? So when if I have to if I have to show you some the function, you'd see that I've simply set the my subplot size, then the title, then I have run one for loop of range up to range 20, where I'm just simply plotting each and every first images of thousands. Okay, it's just simply matplotlib functions. I won't be wasting time to explaining you these silly functions. Okay, now this cell is to show what are the data set we have for the last 5 categories. So yeah, so these are the last 5 categories where you see we have dog, horses, trucks, ships, and what we have more, frogs, right? Okay, so now we need to set the number of classes and the input shape. Let's do that. Input shape of 32 into 32 matrix. Okay, now define two groups of layers, feature layers and classification layers. Okay, in our feature layers we have one convolution layer and with one activation function with ReLU, then another convolution layer with activation function ReLU, then one final max pooling 2D layer that will pull the important pixels from our images, then one dropout layer to kind of reduce the overfitting, then finally we will flatten our dataset. So let's simply run this. It done. Then this is our classification layer, like how to classification, like how to classify this is dog, this is cat, all of this thing. We'll use one dense layer, then in hidden layer we'll be using activation function ReLU, and as it is classification function, so in the output we need to use softmax function. Okay, done. Now the next step is to create the complete model by stacking together feature layers and classification layer. Now we simply need to combine these two layers, right? So our model 1 is ready. Now this is the definition of our training model, like how we'll train the model. So you see the definition train model will be passing model, train, test and number of classes as parameters. Here is our X train, X test. Then our X train and X test are in the data type of float. And then we need to generalize that by dividing with 255. Okay. Then we're simply printing our X train shape. Then here we need to convert class vectors to binary class matrices. Here we simply will compile the model with loss function of categorical cross entropy and optimizer of Adam with a learning rate of very small 0.001. Okay, and we'll be taking epochs of 20 epochs. So let's run this training function, and here we go. Okay, so now it's time to train the model for the 5 categories. So let's do it. Okay, it's giving me some error. Arguments not recognized, error 0.001. Let me see, it has error, right? So let me just change it to, wait, let me just change it to learning model, right? Learning rate. Now okay, now let me see, it should work now. So yeah, I just gave it a very short name, seller, so it not might work sometime. So it will take like couple of seconds, not minute, like it will take definitely more than minute. So let us wait. So all right, so here you could see that it has taken us around 56.86 seconds to train our first 5 categories of data, and the accuracy that we have got is around 78%. Not bad. Now let me see some our summary. So here's the thing, and here you'd see that how much, here the most important thing to see, key, what are the non-trainable parameters. You'd see 0 because we have trained all the parameters, right? Okay, right, now it's time to build our second model. Now here the most important part comes, which is called freeze the feature layer, and then we need to rebuild the model, right? So here are some definition of this process. It says ki this freezing and feature layers, this freezing of feature layers is at the heart of transfer learning. Why? Because this is allows reuse of pre-trained model for classification tasks, because users can just stack up a new fully connected layers on top of the pre-trained feature layers and get good performance, right? So let's do that. Let's run this layer. So you would see that for L in feature layer, we are simply L.trainable, we are giving it false. So we are freezing this layer. Next, again we need to stack up our feature layers and classification layer for the model 2. Then the model summary. Let's do it. Now here the most important part is key for the model summary of the first model. You would see that the non-trainable params are 0, but here the non-trainable parameters are 38,720 because we have freezed the output layer, because there are some because there are some non-trained parameters are there. Now we train the model and we'll see how it takes less overall time and still gets equal or higher performance. So this is our model 2 where we are passing X train GTE5. So you could see if you compare. So here you would see that the last 5 layer is been named as X train GTE5, right? So in the second model we are passing our GTE5 data. So let's do it. So again it has 20 epochs. It will take some time, so let us wait for maybe less than our previous time, which was 57 seconds, right? And you see that the speed is much more better than the previous one, right? And you can also see the accuracy here. You see 91 already, and it's done. Yeah, so 31 second. So the first one was 56 second, this one is 31 second, and the accuracy is 92 in here, like 92 for the training, and for testing we have 84%. So that's what I'm talking about. It will take much less time, much less computational like power, and much less data, right? Now simply we'll plot a bar chart where we'll see how much time taken for the model 1 and the model 2. So let's run this and you'd see that this is our model 2 and our model 1. So model 1 is taking less time. Okay, so this is a summary that I've taken in here, that our model 2 was initialized a fresh model consisting of untrainable convolutional 2D layer and trainable fully connected layers. The convolutional 2D layers weights were transferred from a previously trained model 1 model. Okay, not only did the model 2 train faster than model 1, it also started at a higher baseline accuracy and achieved better final accuracy for the same number of epochs and identical hyperparameters. And it achieved this training on images which were not seen by model 1. Right? So this is the essence of transfer learning. So this is the image. The knowledge we gain from these 5 image, we use that to predict this 5 image. And that's it. This is all about transfer learning, and we'll be building much more project in future with using multiple transformers. So yeah, thanks for watching. And if you like the video and if you feel I have been able to give you some information about what transfer learning is, likes and share and subscribe, whatever you gonna need you do. And of course I didn't share everything because there are lots of things and I myself don't know everything. So whatever I know, I try to give you some basic understanding of what is transfer learning. So yeah, thanks for watching.